This is Pre-Calculus Concept 8D. We're going to look at reflections and functions that are very similar to each other, but their equations are going to differ with a sign, a negative sign, and their graphs are going to differ as reflections of each other. Alright, so box 1 is going to be a concept here. When you see a negative sign in front of a function, it is going to be very closely related to the original function without the negative sign, and the change that we're going to see is a reflection through the x-axis. So what we want to think about here is that every point on the original graph of f of x is basically going to be mirrored through the x-axis. Alright, so being mirrored through the x-axis means basically that the x value will be exactly the same, but the y value will be the exact opposite. So for example, if you had a point up here that was 2, 1, then the mirrored point or the reflected point would be 2, negative 1. So again, anytime you have a negative sign out front of a function, you're going to be reflecting that original function through the x-axis. Alright, sometimes you'll see the negative sign in a different place, so if the negative sign is inside of the function, like this example, then it's going to be a mirror or a reflection as well. This time it's going to be reflected through the y-axis. So if I go over here again and look at a point, let's say it was 3, 5, what the reflected point or the mirrored point is going to be is the exact same coordinates, except the x coordinate will be the opposite. So this would be negative 3, 5. Alright, so those are what to watch out for when you see negative signs in your functions. You're going to see reflections in the graphs. Alright, box 2 is an example. We're going to take one of our common functions, in this case the square root function, and then we're going to think about transforming it by throwing a negative sign in here. Alright, so we can see that the original function f of x equals the square root of x, and our new function g of x equals negative square root of x is two equations that are two functions that are very similar. The difference is you have a negative sign out in front, right? And so we want to remember that that's going to be a reflection through the x-axis. So I'm going to draw a little line that's going to be our mirror. Every point is going to be reflected, so 9, 3 would become 9, negative 3. And 4, 2 would become 4, negative 2. And 1, 1 would become 1, negative 1. So what we're going to get in the habit of doing with these transformations is keeping track of a couple points. So you should be able to generate points on the original function pretty easily. Those are common functions you should be familiar with. And then simply just think about what happens when the points are changed. In this case, they're all going to be reflected of each reflections through the x-axis, and our g of x function will be the red function down here. Alright, box 3, another example. We're back to our common function once again of f of x equals square root x, and now we have g of x that equals the square root of negative x. So notice that our negative sign is inside the function this time. That's a different transformation. It's still a reflection, but this time it's a reflection through the y-axis. Alright, if I track my points, I'm going to think about each and every one of these points being reflected, but this time reflected through the y-axis. Here's 9, 3. Way over here. Negative 9, 3. After you reflect the point 4, 2, when you reflect it, will become negative 4, 2. And the point 1, 1 becomes negative 1, 1. Okay, once again, all of your original points on the common function are reflected through the y-axis this time, and you end up with a function that looks like that. That's our g of x function. Some of you may have looked at this equation and said, I can't take the square root of a negative number, and that's exactly right. You cannot, but notice that all the inputs on the red graph over here are negative numbers, and so when you take the opposite of a negative number, you get a positive number, and therefore you can do the square root. So everything works out there, and that's what your g of x looks like. All right, box 4 is a u-try. This time, instead of a common function, I picked a kind of a strange, unusual function and just gave you what it looks like. There's two versions of the same function down below, so this is going to be f of x. What your job is going to be is to try to graph a graph of negative f of x on one of your graphs. So let's do that over on the left. And also you're going to sketch a graph of f of negative x over here, and that's going to be, we're going to define that as h. Okay, take a minute, see if you can jot down what you think those graphs should look like, and check to see if you're on the right track. Alright, here's the pictures you should have come up with. The left graph are g of x, which is the opposite negative f of x, is going to be a reflection through the x axis. What we're going to expect you to do is be able to track those points. So the point 1, 2 becomes 1, negative 2. The point 3, negative 2 becomes 3, positive 2. And then 5, 0, if you take the opposite of 0, you get 0, so that point actually stays the same. The green graph on the right is the graph of f of negative x. That's the other reflection through the y-axis. In those points, the x-coordinate becomes the opposite. So 1, 2 turns into negative 1, 2. 3, negative 2 becomes negative 3, negative 2. And 5, 0 becomes negative 5, 0. A big part of reflections is keeping straight which type of change gives you a reflection through the x-axis and which gives you the change reflection through the y-axis.